Hi, this is JD, and what we're going to be looking at in this lecture is radicals, simplifying radicals and looking at the rules. Here's a little preview. We're going to go over rules of exponents, radical expressions, square roots and cube roots, and rules of radicals. This unit is more of an introduction to radicals, and the next unit is you're doing more things with radicals. All right, so radicals are related to the exponent rules. The square root or cube root is practically the same as a rational exponent or a exponent as a fraction. So all these rules apply. Specifically, you want to look at the power rule for products and the quotient rule. So if I look at this and consider a square root, I can take the square root of each of these because they act the same way as exponents. Same thing if I'm dividing, I can take the square root of the numerator and the denominator. So radical expressions, here are some rules, or the way to think about it. So the opposite of squaring a number is square rooting a number. So if I consider 7 squared is 49, I consider negative 7 squared is equal to 49. The square root of 49 would be 7, because the opposite of squaring a number is square rooting a number. So to work backwards, when I square, I can square root. Now to get this negative is a little tricky. You could just put a negative in front. So the negative of square root of 49, technically you're doing the square root of 49 first. Order of operations would tell you to do the grouping symbol here. It's like an exponent. So you're doing that first before you multiply the negative. So you do the square root of 49, which is 7, and the negative comes along for the ride. All right, so now let's look at some examples. So it says simplify and assume that all variables are negative real numbers. So the square root of 25, what times itself will give you 25. That would be 5. Or you could say what squared would give me 0. 0. What times it's, so square root of 16 over 49, what times itself will give you 16 over 49, 4/7. You can even type some of these on your calculator. So you can do the square root of 0.36 on your calculator, and you'd get 0.6. Or you can ask yourself, okay, what times itself will give me 0.36, and that would be 0.6. Now what about variables? So like the square root of x to the 8th. Well, you could do the same thing. So what times itself will give you x to the 8th, and that would be x to the 4th. Where is that? That should be a 4. Let's continue. So the square root of 36x to the 6th power, what times itself will give you 36, which would be 6, and what would give you x to the 6th? X to the 3rd. Now what you can also do, since it's a square root, it's implying that there's a 2 here for the radical. So you can divide. So 2 goes into 6 how many times? 3. 2 goes into 8 how many times? 4. Square root of 4 is 2, but that negative comes along for the ride. So you can do it this way. Square root of 4 is 2, negative 1. Now, whatever is in front of the radical, and there's no operation, like here you would assume that's a negative 1 in front. So the operation is multiplication. Just like parentheses, or just like when you have a number right next to a variable, that indicates multiplication. Square root of negative 4 would be not a real number, because what times itself will give you a negative. You look at all the real numbers, no real number would do that. So like negative 2, if you said that's negative 2, negative 2 times negative 2 gives you a positive 4. So that doesn't work. 2 times 2 gives you positive 4. If you do 2 times negative 2, those numbers aren't the same. And what the square root is asking is what times itself will give you that number. So if you ever see a negative underneath the radical, or underneath the square root, then it's not a real number. It would be what's called imaginary. But you don't have to be concerned about those. So what are square roots and cube roots? So we know what square roots are, right? So square root of 4 is 2. The question that we're asking ourselves is what times itself, or what times itself 2 times or twice will give me 4, or what squared will give me 4. Cube roots are similar. So with cube roots, let's say that you have the cube root of 8, that would be 2. Why would it be 2? Because you're asking the question, what times itself 3 times will give me 8? Or what times itself thrice will give me 8? 2 times 2 times 2 gives me 8. So 2 would be the answer. Or I could say, what cubed will give me 8? 2 cubed gives me 8. So 2 would be my answer. So let's do some cube roots. So the cube root of 0, what times itself 3 times will give me 0? 0. 0 times 0 times 0 gives me 0. Cube root of negative 8, what times itself 3 times, or what cubed gives me negative 8? And that would be negative 2. Cube root of 1 over 64, what times itself 3 times will give me 1 over 64? And that would be 1/4. And you can check this by doing the opposite. So the opposite of cube rooting is cubing. So you can take 1/4 and raise it to the 3rd power, and that should give you 1 over 64. What is the cube root of 64? It would be 4, because 4 times 4 times 4 gives you 64. All right, so let's look at some more rules with radicals. So these pertain particularly to the signs. So we saw this in those previous examples. Now the index, that's this number here attached to the radical. The radicand is what's underneath the radical. So it must be positive, because if it's not positive, if it's negative, then it's not a real number. 4th root is the same as the cube root, and then square root. It's asking itself, what raise to the 4th power will give me 81, and that would be 3. Now, if the index is odd, the radicand, what's underneath the radical, can be any number. And notice that the signs are going to match. So the cube root of 27 is a positive 3. The cube root of negative 27 is negative 3. And it's just like exponents. When the exponent was even, you always got a positive result. When the exponent is odd, it retains its sign. Now, if they are the same, so if this is raised to a certain power, and that power is, the index is the same, those would cancel out, but with even, the result is always positive, so you use the absolute value bars. If n is odd, then it doesn't matter because it will just retain its sign. So you can kind of use these as shortcuts depending upon the situation you have. But it is the same as dividing. So if I do n divided by n, that gives me 1. N divided by n, that gives me 1. So you can kind of see the exponents rules popping their head here and there. Alright, so let's look at some examples using these rules. So with the first one, when there is no number for the index, you can assume that it's an even number 2. Square root, square is a reference to 2. So you would take the square root of a square, they undo each other, but it's going to be the absolute value of negative 5, so the result is 5. Letter B, and here we're going to assume any real number if it's just non-negative numbers. So if it's just positive numbers, then you don't have to worry about the absolute value bar when it comes to variables. But here you do. And so this is a 2, and like I said, it kind of works like division. So 2 goes into 6 3 times, and it would be the absolute value here because you don't know if x is positive or negative, but you know that the result has to be positive. The 4th root of any negative number would be not a real number. And the cube root of negative 3 cubes, they're opposites of each other, but remember it retains its sign, so that would be a negative 3. Letter E, you have the square root of 36, which is 6, and x squared, which is, you take the square root of that, they're opposites of one another, so it just cancels out. So you can write it one or two ways. You can write it as the absolute value of 6x, because again, you don't know if x is positive or negative, but you know that the result has to be negative because it's a square root, it's an even root. Or you can write it this way: 6 times the absolute value of x. Either way is correct. Alright, so with these rules, they're going to look more like the quotient rule and the product rule to exponents. So we looked at this one before. This is with the assumption that the variable is any sign, so either positive or negative. But in some sections, you don't have to worry about that much with the absolute value bars. So just pay attention to the directions. You can also get a gist of what they want as far as looking at the example problems. So if I take the square root and it's a times b, I can separate that and do the square root of a times the square root of b. And this also applies to numbers that are outside the radical. As I said before, it would indicate multiplication. If it was addition in between these, you can't separate them. They have to be either multiplying each other or dividing like the second one. So if it's the square root of a over b, I can separate those as the square root of a over the square root of b. Now, since these are equal signs, I can go in either direction. Now, this n right here just means any number, so it could be a cube, it could be 3, it could be 4, it could be 5, it could be anything. This is more general. This is with square roots, so they're really just the same rules, and they are just like the quotient to exponent rule, or it's a power rule, or the product to power rule with the exponents. Alright, so let's look at these and simplify them. So with the square root of 2 times the square root of 7, I can combine those. I can switch it so that they're both underneath the radical, and they both have to be the same radical. If they're different, you cannot do this. You have to do something else, which is outside this course. So you can multiply 2 and 7 together and get the square root of 14. We can do the same thing with 2 and 32, and I get the cube root of 64. Well, the cube root of 64 would just be 4. Square root of 9 25ths, I can take the square root of the numerator, square root of the denominator. Square root of 9 is 3, square root of 25 is 5, so that would be 3/5. With the fifth root, I can do the same thing. So the fifth root of 7 and the fifth root of 32x to the fifth. Now I can treat these separately. I can't do anything with the top. That's just a 7. The cube root of 32 is 2. 2 to the fifth is 32. X to the fifth, the fifth root of that, those are just opposites, so they would cancel each other out. So the fifth root of 7 over 2x. Let's look at some more examples. How you would use these rules differently. So with the square root of 18, I can actually split that apart to simplify it. So I can look for the largest square that goes into 18, which is 9, and split up 18 as 2 times 9. Then I can take the square root of each of those. So the square root of 9 is 3, and square root of 2, I cannot do anything with it. So that would just be square root of 2. Now at this point, you could do square root of 2 times 3 without the 3 being underneath the radical, but I would recommend doing it this way: the number that's outside the radical first, and then the number that's inside the radical second. So 3 square root of 2. The reason for that is when you get into the next section and you start using different properties, combining terms, different ways of simplifying radical numbers, it's going to make it easier. And when you're simplifying, it might look a little bit more complicated, but your real concern is simplifying what's underneath the radical. That should be looked more simplified. Now the cube root of 40 can be separated. Now you could look for the largest square that goes into 40, which would be 8. But what you can also do with cube roots, you can also do this with square roots. With square roots, you're going to look for a pair. With cube roots, you would look for 3 of a kind. And so that 3 of a kind come out, it just becomes 1, 2. And that 5 just stays underneath the radical because you didn't simplify it. Whatever simplifies comes out of the radical. Whatever doesn't simplify, or you haven't taken the cube root of it, stays underneath the radical. Now let's look at letter C, which is 2 square root of 81 y to the 5th. So the square root of 81 is 9. The square root of y to the 5th, this would be 2 as an index, so you can divide. 2 goes into 5. You can only do these with exponents. So 2 goes into 5 twice with a remainder of 1. Now what's on the outside, as I said earlier, is all just multiplication. So this would be 2 times 9y squared, all being multiplied, and then square root of y. To simplify that, 2 times 9 is 18. You can't do anything with the y squared, so you would just leave it. And you would leave everything else. Now with something like this, you don't have to be concerned with those exponents because you can just use division to simplify them. So focus on the number first. We'll separate that. The largest square that goes into the largest cube that goes into 24 is 8. So I can separate it as 8 times 3. Keep those the same. And then take the cube root of each of these. So the cube root of 8 would be 2. The cube root of 8 to the 9th would be a cubed. And the cube root of b to the 4th, 3 goes into 4 once, with 1 left over, and that leftover always stays underneath the radical. Letter E, since these are both underneath the square root, I can cancel the 5 with the 80. So that gives me the square root of 16y over 3. 80 divided by 5 is 16, so that's where that's coming from. And then what you can do is just take the square root of the top. So the square root of 16 would be 4. Square root of y doesn't simplify, so it would just stay the same. And that would be your answer. And that's it. So let's review. We went over rules of exponents because there's a relationship between the rules of exponents and with radicals. And that is the rules look really, they are the same. What's going on in the background is that a radical is just like a fractional exponent. That's why at times we're dividing to simplify. We looked at the different rules for radical expressions. We looked at square roots, cube roots, rules of radicals. So with radicals, if you recall, if it's like a cube root and you're taking cube root of a number, then the signs are retained. So if you're taking cube root of a positive number, you get a positive result. If you take the cube root of a negative number, you get a negative result. With square roots, they work a little differently because you always need a positive result. So the square root of a number, of a positive number or 0, will give you a positive result or 0. If you take the square root of a negative number, you end up with not a real number. And then we looked at some more rules with radicals, and if I have square root of a series of multiplication underneath the radical, then I can take the square root of each number or variable. Same thing when you have like a fraction. So you have square root of a fraction, you can take the square root of the numerator and the denominator. And the other thing, yeah, and that's it. That marks the end of this video. Please like, share, and subscribe. And if you have any questions, put them in the comments below. Thank you, and I hope you have a wonderful night.